Hello everyone. In the last classes, we have discussed about the different kinds of congruence rule, such as the side-angle side congruence rule, angle-side angle congruence rule, and angle-angle side congruence rule. Now today we are going to discuss in this video about two other such congruence rule, that is the SSS congruence rule and the RHS congruence rule. So let us begin with the SSS congruence rule, or which we also known as side-side-side congruence rule. Now what does this rule states? The rule states that if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Now we know that in a triangle there are three sides. Now if we take two such triangle in which the three sides of one triangle is equal to the three sides of the other triangle, then we can say that both the triangles are congruent. So let us see how to prove it. Let us take two triangles. So we will take two triangles, triangle PQR and triangle XYZ, such that PQ is equal to XY, QR is equal to YZ, and PR is equal to XZ. So all the three sides are equal. We will consider it. Next thing what we need to prove here is that we need to prove that triangle PQR is congruent to triangle XYZ. So this is what we need to prove. Now for this we need to do some extra construction. So what extra construction we have done? As you can see already, we have taken a point W, then we have joined point X to point W by intersecting it through the side YZ, and then we have joined the vertices Y and Z with W, forming a triangle. Now while forming a triangle, there is a condition that we have applied here, that this side WY will be equal to PQ and this angle Y will be equal to angle Q, or you can say angle WYZ is equal to angle PQR. So after that we are going to now prove. Now directly we are not going to prove that this triangle PQR is congruent to triangle XYZ. Instead of that, first of all we will try to prove that this triangle PQR is congruent to triangle WYZ or not. So we have considered the two triangles PQR and triangle WYZ. Now in these two triangles, which things are common? So PQ is equal to WY. Thus now we have written it in construction. So by construction we can say that both are equal. Then angle PQR is equal to angle WYZ, that is also by construction. And then we have QR equals to YZ, which is already given to us. So by side angle side congruence rule, we can say that triangle PQR is congruent to triangle WYZ. Now what inference do we get from here? We get that angle W is equal to angle P. So both these angles are equal by CPCT. So we'll mark it as equation 1, which you can use it later on to prove what is called this congruence rule further. So now let us see the next part. In the next part, here now we are going to show the congruency of triangle PQR with triangle XYW. But before that we have to consider the triangle XYW. So in triangle XYW, what we have? We have PQ equals to WY. Then we have PQ equals to XY, which is given to us. So therefore we can say that since you can see here PQ is equal to WY as well as PQ equals to XY. So can we say from here that WY equals to XY? Yes, obviously, because things which are equal to the same things are equal to one another. We have learned this in Euclid's postulates. So since they are equal to the same thing, that is PQ, so both of them can be equal. Now next, WY equals to XY. Now where is WY? If you see carefully, this is WY, and where is XY? This is XY. Now if you consider this X, Y, W as one triangle, then this side, which corresponding to this side, which is the opposite angle? This is the opposite angle, angle 1, and corresponding to this side, which is the opposite angle, this is the opposite angle, angle 2. Now we know that a theorem that if the sides are equal, then the angles opposite to the equal sides are also equal. So we can say that angle 1 equals to angle 2, and we'll mark it as equation 2. Now similarly we can also prove in the other half, as you can see in triangle XZW, we can also prove here that angle 3 is equal to angle 4 in a similar fashion. So we'll mark it as equation 3. Now we have to add equation 2 and equation 3. Now if we add equation 2 and equation 3, how will we add it? It's very simple. We will add the left hand side with the left hand side and right hand side with the right hand side. So we'll get equation 1 plus equation 3 is equal to, angle 1 plus angle 3 is equal to angle 2 plus angle 4. So what is angle 1 plus angle 3? That is nothing but angle X, as you can see here in the figure. Angle 1 plus angle 3 is what? Angle X. Similarly, angle 2 plus angle 4 is what? Angle W. Now from 1, we've already got in our previous slide that angle W is equal to angle P. After showing the congruency of triangle PQR and triangle WIZ, we got that angle W was equal to angle P. Clear? Now here we are getting that angle W is equal to angle X. So what can we infer from here? Yes, we can infer that angle P is equal to angle X. And that we will mark as equation 4. Now moving on. Next what we will do? Now next we are going to compare what we actually need to compare or what we actually need to prove. Now we are going to prove that is triangle PQR congruent to triangle XYZ or not. So if we take these two triangles PQR and XYZ, what we have? PQ equals to XY, which is given to us. Then angle P equals to angle X. This is also we got just now from equation 4. Then PR is equal to XZ. That is also given to us. So now we can say that triangle PQR is congruent to triangle XYZ by side angle side congruence rule. Now you might be thinking why we have first not shown the congruency of triangle PQR and triangle XYZ. We could have shown it. But the process is we have to, instead of directly showing the congruency, we have to show it in this fashion. Because we cannot, as I already said in the earlier congruence rules also, that what is given to us, we are not applying that directly to prove the congruence rule. We are applying some other congruence rule to prove the given congruence rule. And whatever the congruence rule states in the statement, that we take as the given part. Clear? So here you can see by SAS congruence rule, we are proving this SSS congruence rule. Clear? So this proves the side congruence rule. Now moving on to the next congruence rule, that is the right angle hypotenuse side, or we can say the RHS congruence rule. Now this congruence rule is applied only in the case of two right angled triangles. Till now whatever the other four congruence rule we have discussed, they can be applied to any triangle. But this RHS congruence rule can be applied only when the two triangles are right angled triangle. So let us see what the statement says. If in two right triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. So we know that in a right angle triangle, there is the hypotenuse, there is the perpendicular height and the base. So we have to consider the hypotenuse of one triangle and any one side of the triangle. If they are equal to the hypotenuse and any one side of the other triangle, then we can say that both the triangles are congruent to each other. So let us prove it. We will take two right angle triangles ABC and DEF, right angled at B and E. So angle B and angle E will be 90 degree. and the hypotenuse, that is AC, will be equal to the hypotenuse DF, and other side, that is BC, is equal to EF. So this is given to us. Now what we need to prove? Simple. We need to prove that triangle ABC is congruent to triangle DEF. This is what we need to prove. So let us prove it. So first of all, we will consider one triangle. First we will consider the triangle, right angle triangle ABC. In right angle triangle ABC, if we apply the Pythagoras theorem, then what we get? If we apply the Pythagoras theorem, we get AC square equals to AB square plus BC square, or which we can even write in this way: AB square equals to AC square minus BC square, because AB square is not highlighted in this question, so we are considering AB square, and then whatever is given to us, that AC square and BC square, we are taking it in this way. Similarly, in triangle DEF also, right angle triangle DEF, we can write by Pythagoras theorem, we can write that DF square equals to DE square plus EF square, or which can also be modified as DE square equals to DF square minus EF square. So that will be equation 2. Now what we'll do, we will, from the equation 1, we will now modify the equation 1 by substituting some other values. So what we have done is that in equation 1 we have this AB square equals to AC square minus BC square. There we have substituted in place of AC and BC, DF and EF, because we know that AC equals to DF and BC equals to EF. So in place of AC and BC, we have just substituted it with DF and EF. Now we got this AB square equals to DF square minus EF square is what? It is DE square. We got it already in our previous equation 2. Now we will remove the square terms. Then we will get AB equals to DE. So that will be equation 3. Now in triangle ABC and triangle DEF, we got all the sides equal. So AB equals to DE, just now we got. Then we got BC equals to EF, already given to us. And AC equals to DF, this is also given to us. So by side congruence rule, we can say that triangle ABC is congruent to triangle DEF. So in this way, we can prove the right angle hypotenuse side, or the RHS congruence rule. Clear? Now let us see some examples where we can apply these congruence rules. So the first example says AB is a line segment. P and Q are points on the opposite sides of AB such that each of them is equidistant from the points A and B. Show that the line PQ is the perpendicular bisector of AB. So let us see the figure first of all. As you can see in the figure, AB is a line segment. Now there are 2 points P and Q which are equidistant from AB. So equidistant means if we join both these points with the line segment AB, say for example, if we join the point P with AB, we get PA and PB. So PA and PB will be equal because both of them are equidistant from P. Similarly, if we join the points A to Q and B to Q, then these two are also equal because they are equidistant from Q. Also, it is given that PQ, if we join P and Q, then it is a perpendicular bisector. That means it has bisected this line segment AC, as well as it is bisected at right angles. Clear? So these things, okay, this is not, we have to show this. Okay, this is not given to us, we have to show this. PQ is the perpendicular bisector, we have to show this thing. So that means we have to show that AC is equal to BC and angle PCA is equal to angle PCB. This is what we need to show. So already I have discussed that given PA equals to PB, QA equals to QB, to prove AC equals to BC and angle ACP equals to angle BCP, and that will be equal to 90 degrees. This is what we need to prove. Now for proving part, we will take two triangles PAQ and PBQ. In triangle PAQ and PBQ, what we have? AP equals to BP. Clear? This is given to us. AQ equals to BQ. This is also given to us. And PQ equals to PQ, which is the common side. So by SSS congruence rule, these two triangles are congruent. Now from here, what we can infer? We can infer that angle APQ is equal to BPQ. Simplicity. Now, again in triangle PAC and PBC, what things are common? AP equals to BP, angle APC is equal to angle BPC. Okay, now if you see here, APC and APQ, are they not the same triangle? Are they not the same angle? Yes, they are. Just this C has been extended to Q. That's it. But the angle remains the same. So instead of writing APQ, we can now write APC. And instead of writing BPQ, we can write BPC. So that is the reason given as APQ equals to BPQ. So we can write APC equals to BPC. Now, PC and PC, that is common. So both the triangles PAC and PBC are congruent by SSS congruence rule. Now from here, what we can infer? Since triangle PAC is congruent to triangle PBC, so AC will be equal to BC. So this has proved our first part. So we'll mark it as equation 1. Next, another thing we can infer here is that angle ACP is equal to angle BCP. Now if you look carefully, angle ACP plus angle BCP, they will be equal to 180 degree because it is a linear pair. So now we will substitute, in place of BCP we will substitute ACP. So we get twice ACP, that will be equal to 180 degree. So from there we get ACP equals to 90 degree. So which will be also equal to BCP. So both of them are 90 degrees. That is equation 2. So from equation 1 and equation 2, we can easily conclude that PQ is the perpendicular bisector of AB. So this proves the given question. Now let us move on to another example. That is, P is a point equidistant from two lines L and M intersecting at point A. Show that the line AP bisects the angle between them. So we have to show that AP is the angle bisector. So let us see the figure. So this is the figure. As you can see, L and M are two lines intersecting at a point A. PB is perpendicular on this line L and PC is perpendicular on this line M. Now we have to show that this PAC is equal to PBC. This is what we need to prove. We need to prove that PA is the angle bisector. Clear? So let us prove it. So first of all, we'll write down what is given to us. PB equals to PC because they are equal, or you can say they are equidistant. So PB will be equal to PC. And angle PBA equals to angle PCA. Both are 90 degrees as they are perpendiculars. Now we have to prove that angle PAB equals to angle PAC. So for that, we'll consider the triangle PAB and triangle PAC. In both this triangle, what we have, PB equals to PC, that is given to us. Angle PBA equals to angle PCA, both are 90 degrees. And then we can write PA equals to PA, that is the common side. So both these triangles are congruent by right angle hypotenuse side congruence rule, or the RHS. Now why we have taken RHS? Some might think it to be SSS. No, why it is RHS? Because both these are right angle triangles. So remember, if it is a right angle triangle, and here PA is what? PA is the hypotenuse of both the triangles. Angle PCA is what? It is the right angle. And PB and PC are what? They are the other side. So here, right angle is also there, hypotenuse is also there, angle is also there, the side is also there. So we can use the RHS. Both of them are right angle triangles. Clear? So if you find any right angle triangle and if it is satisfying all these conditions, then we can definitely use the RHS congruence rule instead of using SAS or any other congruence rule. So now from here we can infer that angle PAB equals to angle PAC by CPCT. So this proves our required question, what is required to be proved here. So I hope you all have understood these two congruence rules, SSS and RHS, as well as you have understood these two examples. Now there are various examples given in the exercise. You can try it out by applying these congruence rules. So that brings us to the end of all the 5 congruence rules. In our upcoming videos, we'll discuss further topics in this chapter. Till then, thank you and have a nice day.